Hello Makkali, welcome back everyone to my channel. In this video we are going to see chapter 1 electric charges and fields. Okay, physics class 12. So first we have to know what is electrostatics. Okay, it is a branch of physics which deals with the study of charges which are at rest. Okay, so in this chapter we are going to deal completely of the charges which is at rest. So first topic we are going to deal here is electric charges. Okay, so the electric charges was actually taken from the Greek word which means which is electron and which means amber. Okay, so many pair of materials are those which on rubbing could attract light objects and they are said to be charged or electrified. Okay, first let's consider one example such as comb. Okay, so comb will be whenever we bring piece of paper near the comb attracts those piece of papers. Do you know why? This is because whenever we just rub the comb on a dry hair and it is actually acquiring some charges, and that charges are responsible for the attraction of those papers. Okay, so the quantity of electricity held in an object is called as electric charges, and we say the comb has been charged or electrified. Okay, so whether it happened also with metal comb, no, it does not happen with metal comb. This is because metal is good conductor of electricity. Therefore, it allows the electric charges to flow onto the earth. Whereas we consider the plastic comb is actually a bad conductor of electricity. It do not allow the electric charges to flow onto the earth. Therefore, the electric charges are actually inside that comb, which is helpful, which attracts the pieces of paper. Okay, this is an example we can say on rubbing the object could attract the light objects. Okay, the two kind of charges are positive charge and the negative charge. Okay, we know that like charges at repel and unlike charges attract each other, and the property which differentiate the two kind of charges we call as the polarity of the charges. And now the electric charges we represent by capital Q or the small q. Okay, and the SI unit of electric charge is coulomb. And the next one we are going to deal with is unification of electricity and magnetism. First, let's consider a compass, magnetic compass, and which is placed near a wire where there is a electricity passing through them. Okay, so whenever an electricity is passing through them, the compass needle shows some deflection. This is because the electric charges which are in motion produces some magnetic field, and these moving magnets produce some electricity, and these independence of these electricity and magnetism we call it as the electromagnetism. So the next topic we are going to deal with is gold leaf electroscope. It is actually a very important question that we are going to get in our board exam. Okay, so this gold leaf electroscope is an apparatus or a device which is used to detect the charge on the body. So it consists of, this is the vertical metal rod. Okay, so this is the vertical metal rod, and this is the gold leaves which are attached at its bottom, and at the top of the metal rod there is a metal knob. So whenever a charged body is just touches the metal knob, the charges passes through the horizontal metal rod, and next it flows onto the gold leaf, which shows the leaf shows some divergence. Okay, and the degree of divergence of the gold leaves will tell the amount of charges on the body. Okay, only this much is the gold leaf electroscope. For this we have to write the gold leaf electroscope is used for or it is a apparatus or a device which is used to detect the charge on the body. Okay, and next we have to draw this diagram. Okay, this whole diagram we have to draw. Next, why material body acquire charges? We know all the matters are made up of atoms and molecules. Okay, although the materials are actually neutral, they do have some charges. That is, the positive charge in them are also equal to the negative charges. Okay, the amount of positive charge present in them will be equal to the negative charge. So therefore exactly balanced. To electrify a neutral body, we need to add or remove one kind of charges. Okay, when we say a body is charged, we always refer to this excess charge or defect of charges. In solid, some of the electrons being less tightly bounded in atom are the charges which are transferred from one body to another. Okay, so in this topic what we have to keep in mind is the body which loses the electrons are positively charged and the body which gains the electrons are negatively charged. Okay, so negatively charged body which gains the electrons, and next one is positively charged body which loses the electrons. And here, when we rub a glass rod with silk, some of the electrons from the rod are transferred to the silk cloth. Thus, the rod gets positively charged and the silk gets negatively charged. No new charge is created in it. Whenever we rub two objects, there is only transfer of electrons, but there is no new charges created. So the next topic we are going to deal with is conductors and insulators. We know that conductors are the substance which allow the electricity to pass through them easily, but whereas insulators are the one which has high resistance to the passage of electricity. Okay, so here one of the 3 mark important question is differentiate between the conductors and insulators. Okay, so here are 4 points given. The first point is substance which allow electricity to pass through them easily is conductors. Substance which offer high resistance to passage of electricity through them is insulators. Next one is the conductors have electric charges that are comparatively free to move inside the material, whereas the insulators do not have the free electrons. And the next one is the conductors, when some charge is transferred to it, it readily gets distributed over the entire surface of the conductor. But whereas in insulators, the charges stay at the same place wherever it has been localized. Okay, and the examples of conductors are metals, humans, animal bodies, and next is earth. And the insulators are glass, porcelain, plastic, and wooden. Okay. Next one is grounding or earthing. Grounding or earthing is just a process of sharing some charges to earth. Okay, so only this much we have to know. What is grounding or earthing? Grounding or earthing is a process of sharing the charges with the earth. Okay, so here it is there. The process of sharing the charges with the earth is known as grounding or earthing. Next one is electrification, which is an important 3-marker question in our paper. It is sure important 3-marker. Okay, for this electrification, first we have to define electrification, and next we have to discuss about the different 3 electrification process. Okay, first what is electrification? A process of charging a body is known as electrification. Okay, so here we have 3 types of electrification or 3 methods of electrification. Okay, so first one is charging by friction, and the second one is charging by conduction, and the third one is charging by induction. So for the charging by friction, first we have to consider 2 bodies. We should rub against each other at some point of contact. Okay, so the electrons from one body is transferred to the other body. Okay, so the electrons from one body is transferred to the another body. The body which loses the electron are actually positively charged, and which gains the electron are actually negatively charged. Okay. And also the positive charges and the negative charges acquired by both the bodies are actually in the same magnitude. Okay, so here, and one more important point we have to keep in our mind is the bodies must be insulators. Okay, so the body which we are taking and rubbing against each other, they must be insulators. So whatever I have explained is only given as the description here. Okay, so if you want you can go through it. And the next one is charging by conduction. Here in charging by conduction, we have to consider a good conductor, and we just have to touch a good conductor by a charged body, whether it can be positively charged or negatively charged. Okay, and this process we call as a charging by conduction, and the charges acquired by these bodies are actually the same nature of the conductor. Okay, that is, if this charged body have positive charges, the charges acquired by the good conductor is also positive. If these have negative charges, the charges acquired by the good conductor is also actually negative charges. Okay. So here also the same will be given whatever I have told. And the next one is charging by induction. In this charging by induction, a good conductor we have to consider, and this good conductor we have to just place it near a charged body. Okay, and the charges acquired by this good conductor will just be opposite to the charges which are in the nature of the charged body. Okay, if a good conductor is neutral and the charged body is actually positive, the charges acquired by the body is negative charges. If the charges of charged body is negative, the charge acquired by the good conductor is actually positive. So whatever I have explained you, the same I have written here. Okay, and the next topic we are going to deal with is charging two metal sphere by induction. For this, first we have to consider two spheres. Okay, let's say A and B, which are supported by a insulating stance. So first, positively charged rod be brought near one sphere. Let's say near A I have brought the positively charged rod. Okay, so the free electrons which are present in these both two spheres will accumulate to the left of the sphere A, or it will be attracted towards the rod. Okay, then all the positive charges present in both the sphere will be accumulated to the right of the sphere B. Okay, so now without removing this rod, we have to separate these two spheres. Okay, if we separate these two spheres, then we can say the negative charges which are present in A will be remaining in A, and positive charges accumulated by B will remain in B. Okay, so if we just remove the rod and then separate the spheres, then the positive charge and negative charge will not be in a single sphere. That means a positive charge will not be in just B, it also will go to A. Okay, therefore without removing the rod, we have to remove this two sphere or separate this two spheres. Okay, after separating this, we can just remove the rod. Okay, and now the separated spheres further apart, and next we are removing the rod, right? So therefore we can say A is completely of negatively charged. Okay, this A is completely of negative charged and B is completely of positive charged sphere. So first we have considered the neutral spheres. Now we have got the charged spheres. Okay, so whatever I have explained is as written in the written here in the notes. Okay, if you want you can go through it. So the same whatever I have written. Okay, and the next one is we have to induction by grounding. So we have to charge, we have to consider a single sphere. We have to charge it either positive or negative, and here not only induction is applied, also grounding we will do. Okay, so that is, first we'll consider one sphere. Let's say A only. Okay, it is supported by a insulating stand, it is common. Okay, and next one is, I'll just bring one charged rod. Okay, here we have to make a metal sphere into positively charged by induction. In induction, we know a good conductor will acquire a charge which is of nature opposite to the charged body. So we need positively charged, and since we have to take negatively charged rod, right? So if we take negatively charged rod, the positive charges present in this A will acquire to the left of the sphere, and the negative charges will acquire to the right of the sphere. So next step is we have to connect that the right side of the sphere to the ground. We have to do grounding so that the free electrons present in A will just go into the earth. Okay, so the free electrons now are without removing the rod, the negative end of the sphere is grounded, right? The electrons now flow into the earth. After that we can remove this rod. Okay, so after that if we just remove this rod, the negative electrons also has been grounded, so only remaining are here positive charges. So therefore sphere A is now positively charged. So we have got positive sphere, we have taken first metal sphere, now we have got positively charged sphere. Okay, so whatever I have explained is given here. If you want you can go through. Okay, see, if a negatively charged rod is brought near the sphere, the positive charges in the sphere are attracted towards the rod and they move towards the left, while the negative charges move to the right. Without removing the charged rod, the negative ends of the sphere is grounded, and the electrons from the sphere flow into the ground. Okay, if the ground is disconnected and the rod is removed, the charge will spread uniformly and the sphere is positively charged. Okay, whatever I have told, the same. And the second one is, we have to charge a metal sphere negative. Okay, charging a metal sphere negatively by induction. So first, what we have considered a metal rod which is supported by a insulating stand, and we have brought a negatively charged rod, right? But here we have to bring a positively charged rod, because we have to get negatively charged sphere, right? So that the negative charges in the sphere will move towards the left and positive charges towards the left. Now we have to connect the right side of the sphere and to the earth, that is, we have to do grounding. Okay, so the electron from the ground will flow into the sphere. Okay, so that after doing this, we have to remove the rod. Until the free electrons flow into the sphere, we should not disconnect or we should not take out the rod. Okay, after that, if we take out the rod, the sphere A will actually have now completely of negative charges, right? So now we can say sphere A is now a metal sphere which is actually negatively charged. Okay, so here we'll see the description. Let a positively charged rod be brought near the sphere. Free electrons in the sphere are attracted towards the rod and they move towards the left, while the positive charges move to the right. Without removing the charged rod, the positive ends of the sphere is grounded and the electron from the ground flow into the sphere. If the ground is disconnected and rod is removed, the charge will be spread uniformly and sphere is negatively charged. Okay, so the next one is electric charges. As we have seen that the electric charge have two type of charges, one is positive and negative, and these effects tend to cancel out each other, and they carried by a body is not affected in its motion. Okay, so but here the electric charges have only magnitude, but they don't have direction. Therefore, it is actually scalar. Okay, it is an important one. Okay, so electric charge is scalar quantity. Okay. Next is basic properties of electric charges, which is an important 3 marker in our board paper. So basic properties of electric charges are 3: additivity of charges, conservation of charges, quantization of electric charges. We should not write that like repel and unlike pole attract and all. Okay, so we should not write that. Basic properties are additivity of charges, conservation of charges, and next is quantization of charges. First, we'll see what is additivity of charge. Okay, so it is a property by virtue of which the total charge of a system is obtained simply by adding algebraically all the charges present anywhere on the system. Okay, if we consider a system A, okay, and the total charge on the system be Q. So the total charge on the system is equal to, there are n number of charges present from Q1 to Qn. So total charge of the system is equal to sum of all the charges present anywhere on the system, which is Q1 plus Q2 till Qn. Okay, and if Q1 is plus 1 and if Q2 is minus 4, we have to take the sign as it is. We should not change the sign. Okay, here if it is plus 1, we have to take plus 1. If it is minus, we have to take minus. Okay. The next one is conservation of charge. It is a property by virtue of which the total charge of an isolated system, this isolated system is actually important for, remains constant or conserved. Okay, so it is, we don't create or destroy any charges, so it remains always constant. Okay, so if we consider neutron and proton also, there is a proton and also electron present in it. Okay, next one is quantization of electric charges. It is a property by virtue of which all the free charges are integral multiple of a basic unit of charge of an electron or proton represented by E. That it says Q is plus or minus Ne. Okay, where Q is the charge on a body. Okay, and N is some integer which can be positive or negative, and minus E is charge of electron and plus E is charge of proton. We know charge of electron or proton is plus or minus 1.6 into 10 power minus 19 coulomb. Okay, so the same is given here. And next, this is like if we have N2 protons and N1 electrons, then Q will be N1 minus E. This is because the charge of, that is charge of electron is actually negative and charge of proton is positive, right? So N1 minus E plus N2 E. So N2 minus N1 is E. So we know N is integer. So N1 minus N2 minus N1 is also an integer. Okay. So the next topic is Coulombs Law, which is an important law that we are going to deal in this chapter, and this we use for many derivations. Okay, so it states that the electromagnetic force of attraction or repulsion between 2-point charges is directly proportional to the product of charge and inversely proportional to the square of the distance between them. Okay, so we can say that F. Okay, so here F, force is directly proportional to the product of charges Q1 and Q2 divided by inversely proportional to the square of the distance between them. Okay, so what do we mean by a point charge? Point charge is actually the size of the charge is very much lesser than the distance between them. Okay, so here, according to Coulombs law, we'll consider two charges, which is Q1 and Q2. The distance between them is R. So F is equal to Q1 Q2 by R square. In order to remove this proportionality symbol, we introduce a constant K, and that K is equal to 1 by 4 pi epsilon naught. Okay, this epsilon naught is a permittivity of free space. Okay, and this K value is 9 into 10 power 9 Newton meter square per Coulomb square. Here it is there. Okay, so this is the K value and this is the permittivity of free space value. And the next one is unit of charge. Unit of charge, we know it is Coulomb, and they'll ask us to define Coulomb. They may ask us define the unit of charge or define Coulomb. Okay, it is an important one marker question which repeats in a board exam. So first we'll consider Coulomb's law, that is force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Here we have to consider these charges as 1 coulomb. Okay, and the distance between them is 1 meter. So force will be equal to 9 into 10 power 9 Newton. So from this we have to frame the definition of 1 coulomb. Okay, so 1 coulomb is that charge which when placed in a air or vacuum at a distance of 1 meter from a equal and similar charges. Okay, they repel, right? If it is a like charges, they repel. So equal and similar charges repel it with a force of 9 into 10 power 9 Newton. Okay, that is given here. So the similar units are 1 mc and 1 mu c. So this we'll use when we solve the numericals. Okay, and here is one more important derivation is in free space epsilon naught we consider, so force is F naught, and in material medium Fm we'll consider. So in material, permittivity of medium is E epsilon. Okay, so on dividing this 1 and 2 we'll get epsilon by epsilon naught, and this F naught by Fm we call as relative permittivity. Okay, so epsilon is equal to epsilon or into epsilon naught. So here permittivity in medium is equal to relative permittivity into permittivity in free space. Okay, and the next topic is Coulomb's law in vector form. Okay, so for this Coulomb's law in vector form, we have to write this two equations. This equation and then is this equation. Okay, and also this one we have to write. And we have to mention R12 is unit vector and R21 also is unit vector. So let's see how do we get that. First we have to consider two charges Q1 and Q2, which is of which has a position vector of R1 and R2. Okay, and the position vector of 1 to 2 is R21, and the force on 1 due to 2 is F12 and force on 2 due to 1 is F21. So now here we can see, here we can use triangular law of vector addition, that is R1 plus R21 is equal to R2, right? So R21 is equal to R2 minus R1. Okay, So R2 minus R1. Here R2 minus R1 also we can write as R12, right? That is minus R12. So therefore R21 is equal to minus R12. Okay. So that is the position vector of 2 due to 1. Q2 due to 1. Okay. So vector form of Coulombs law is F21 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R21 square, where R21 cap and R21 cap is the unit vector along R21. And F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square. R12 cap, where R12 is a unit vector along R12. Okay. And the next one is, if this Q1 and Q2 are of same sign, we can they are like charges, so they repel. So F21 is in this direction, which denotes it is repulsion. And if they are of opposite signs, they attract. Okay, it shows it attracts. It is attraction. Okay, so now is the force between multiple charges. So the principle of superposition. When a number of charges are interacting, the net force on a given charge is the vector sum of the force exerted on it by all other charges. The individual forces are unaffected due to the presence of other charges. Okay, it just says that if we have some charges like Q1, Q2 and Q3, the force this Q2 exerts some force on Q1, and this Q3 also exerts some force on Q1, right? So therefore the charge on Q1 is actually equal to the force exerted by 2 on 1 plus force exerted by 3 on 1. Okay, so let's see now. See the same, we are considering 3 charges. Here is Q1 and Q2 and Q3. The force exerted by Q2 on Q1 is F12, and force exerted on Q1 due to Q3 is F13. So the F1 is actually equal to F12 plus F13. So 1 by 4 pi epsilon naught Q1 Q2 by R1 square R1 cap plus 1 by 4 pi epsilon naught Q1 Q2 by R13 square R1 cap. Here we can see the common terms, 1 by 4 pi epsilon naught Q1 Q2, 1 by 4 pi epsilon naught Q1 Q2. So therefore if we take this out common, we'll get 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught Q1 here it is Q1 is common for both, right? So Q1 and Q1 by 4 pi epsilon naught if we take out common, Q2 by R1 square R1 cap plus Q3 by R13 square and R13 cap. Okay, so if we have n number of charges which exert force on the first charge, that is Q1, we can write this expression as 1 by 4 pi epsilon naught Q1 Q2 by R12 square till Q1 Qn divided by R1 n square R1 n cap. So here we can take out Q1 by 4 pi epsilon naught summation I is equal to 2 to n, where Qi by R1I square R1I cap. Okay, here R1I is actually the unit vector along R1I. Okay.